Ready? Go. Now let's come back to see this question, okay? In this box, we see 4 tickets, 1, 1, 2, 4. And we're gonna make 25 draws with replacement. Since this is with replacement, all the draws are independent draws, okay? Let me write this down. This is with replacement. So the draws are independent. And this is the reason why we can claim what? X1, X2, up to X25 are independent. And what's XK? XK is the number selected on the case row, okay? Now what do we want to find? We want to find how likely sample mean between 2 and 3. Or equivalently, we want to find how likely sample total is between 50 and 75, okay? Claim 1. If x1, x2 up to xn is a sequence of identical random variable, this is first claim we want to show. We claim x1 up to xn is a sequence of identical what? Random variable. And here is 25. First, let's look at the distribution of x1. When I make only one draw from the box, and the first row, x1 means the first row. What can I get on the first row? I can get number 1 ticket. How many number 1 ticket in the box? 2. 2 out of 4. So chance I'm going to get number 1 ticket is 2 out of 4. Okay? Now, how likely I get number 2 ticket? It's also what? 1 over 4. Am I correct? Chance I get number 1 ticket is 2 out of 4. 1, 2, 2 out of 4. Chance I get number 2 tickets, 1 out of what? 4. Okay? How about 4? It's also what? 1 out of 4. Now, since the draw are made with replacement, after I record the ticket, I put it back. So right before I make second draw, x2 is what? The ticket I get on the second draw. The box condition is just like right before the first draw. Is that okay? So in this case, what can I get on x2? I can get x2 as 1, 2, 4. But how likely I'm going to get 1? Chance is 2 over 4. How likely I get 2? 1 over 4. How likely I get 4? 1 over 4. Okay? They looks exactly the same. Can you see that? They looks exactly the same. And keep going this. Every time after you recall what you get on the case row, you put it back. Till the 25th row, okay? Because you put it back every time, so x25 has this distribution. You still can get 1, you still can get 2, you still can get 4. And chance of getting 1 is still 2 over 4. Chance of getting 2 is still 1 over 4. And chance to get 4 is still what? 1 over 4. This is a definition. 2 random variables are called identical if they have the same probability distribution. When we say they have the same probability distribution, not just they have the same possible value. Even for the same possible value, they have the same probability to appear. Same thing for here. 2 has 1 over 4 chance. This 2 is also 1 over 4. Is that okay? So when we say 2 distributions are identical, not just they have the same possible value. Even for the same possible value, they have the same chance to appear. Okay? So this is a very strong condition. Okay? 2 random variables are called identical if they have the same probability distribution. Okay? Now let's stop here. Okay?